I thought it was really important for you guys to understand how to handle data when it comes to these big titration questions that we get a lot of the time in the exams. So what I suggest you do is pause this video and have a read of this question. The reason is my first tip here is to read the entire question. Now, why is that important? Well, what we do when we read the entire question from start to finish is get an idea of what it is we need to calculate, what's going on in the question, in the example, in the titration that they're doing, and of course, what the end game is. So down here, you can see the last question, the end game is to calculate the percentage by mass of sodium hydroxide in the impure caustic soda. So by doing that, like I said, you get an overall view of what's going on and therefore a bit more clarity as to the path which you've got to take in terms of the calculations you've got to do. The second thing I would say after you've read the entire question is pull out all the data. Okay, now what I mean by that is you're going to have two, maybe three main players in terms of chemicals when it comes to these. In this question here, we've got two. We've got sodium hydroxide and we've got sulfuric acid. So I'm going to put NaOH and H2SO4 over here. Now you can do this in an exam if you want, and everyone's got their own way of doing it, but my suggestion is that we go about doing some highlighting. So what do we know about the sodium hydroxide? Well, we know that 2 grams of the impure caustic soda was made up to 250 centimeters cubed of solution. So there's things that we can have. We've got a mass, if I undo that. So we've got a mass, we could have a volume, we could have a concentration, and of course, number of moles is obviously very, very important. So we've got a mass of, well, impure sodium hydroxide. Okay, so I'm going to write that in there. And we've got a main volume of 250 centimeters cubed. Now I'm going to put a slash there because what we also have is another volume. 25 centimeter cubed of this solution was neutralized by the sulfuric acid. So we do have another concentration there, which I'm going to put in red because that's the most important one that we need to use, 25.0 centimeter cubed. So we've got a stock solution here, and this is what's actually taking part in the reaction. Do we know the concentration? No, we don't. Do we know the number of moles of sodium hydroxide? No, we don't. Okay, so we need to actually find out those things through calculations. When it comes to the higher sulfuric acid, we've only got two bits of information: a volume, 24.6, and the concentration of 0.1. Okay, so we've got no mass there for the sulfuric acid. We've got a volume of 24.6 centimeters cubed, and we know the concentration is 0.100. Okay, the number of moles, we're going to have to figure that out. So, third thing, what I would say is these three parts to this question, the questions they ask you, are the three steps that I would always take and you always get when it comes to mole calculations. Okay, I'm going to call them A, B, and C. Step A, I would always say find the number of moles of something, anything, okay, in the equation. We can't find the number of moles of sodium hydroxide, we just haven't got the data. But what we do have is the data to find the number of moles of H2SO4. So number of moles of H2SO4 equals concentration times volume. We've got that, and we can figure out this number of moles here. When it says determine, determine isn't calculate, is it? Notice how we're using this word determine here instead of calculate, calculate. This is down to stoichiometry. Okay, so we're using the stoichiometry to actually find the number of moles of sodium hydroxide we've actually got in this 25 centimeters cubed. Okay, now that's just always the second part. Find the number of moles of something. Second part, use stoichiometry to find the number of moles of something else. All right, and then last but not least, part C. Okay, end game. Now the end game is turning that number of moles that you've just calculated in part B, the second step, to find whatever it is you need. In this case, we need to find a percentage by mass of sodium hydroxide. Once we've got the number of moles of sodium hydroxide, what we can do is we can find the mass very easily. What we can do is mass equals number of moles times molar mass. We've always got access to the molar mass as long as we know the formula of that substance, and that will give us our mass of sodium hydroxide present in 25 centimeters cubed. Now, of course, this is where the larger volume comes into play. They do this a lot. They give you like a stock volume, and it can be confusing as to which one to use, but your stock volume is always the biggest one. 99 times out of 100, they'll use 25 centimeters cubed as the volume in a titration, okay? So 250, all we need to do there to find the mass of sodium hydroxide in 250 in our stock solution, we times it by 10 because it's 10 times as much. And once we've got that, we can find percentage by mass just by taking that mass that we've just calculated, divide it by 2 grams, which is the total mass of the impure stuff, times 100, and that will give us our answer there. So the main things here are, number one, read the entire question first. Get an overall idea of what the question's about and where it's headed. Secondly, pull out all your data. Make it nice and simple for yourself. Maybe write it somewhere else on a separate piece of paper or at the back of the exam paper, anything like that. And then the third thing I would say is your 3-point game for your calculations. A, find the number of moles of something. Anything. There will only be one thing you can calculate the number of moles of, whether it's concentration times volume or mass over molar mass. Second thing, stoichiometry. Use that to find the number of moles of something else, usually the thing that you need to actually play your end game with. In this case, your stoichiometry finds you your sodium hydroxide number of moles, and then of course use that for your end game, which is, in this case, percentage by mass, or it could be a concentration, or it could be maybe even the molar mass of that an unknown substance, okay? Always a 3-point game. So that's how I would handle titration data, and you know what, any other calculation data that you guys come across as well.